Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. Okay, these are the Fourier transform properties that we are going to discuss in this chapter. So you need to have your Fourier transform table or Fourier transform pairs in hand. So the first property that we are going to focus on the linearity and superposition. So when you have a signal V1t, so you'll have V1 omega in frequency domain. If you have V2t, so you'll have V2 omega in frequency domain. But you have a combination of two signals, AV1t plus BV2t. So you'll be having the same scaling factor and same operation in frequency domain. So that is called superposition. Let's look at the first example on superposition. So you need to find the Fourier transform for the given signal 3e minus 2 modulus t. So this equation can also be represented in this signal shape. So it is basically the combination of two signals, one on the left hand side and one on the positive t. So basically when you have a Fourier transform operation, so you need to have your Fourier transform table in hand. So compare the given equation with the equation or the signal you have. So in this case, there's two methods to solve this. The first one is by using the signal given. So this is the first method and this is the second method. So by using the first method, you will consider that this equation includes two components, which are the one with on the left hand side and one in the positive t. Okay, so from here you'll get the basic equation. So you need to compare with the Fourier transform table to get the Fourier transform equation. So from the table, if you have single component AE minus AT UT, so compare with the given equation. For example, the first one you have 1E minus 2T UT. So you know that your small letter a is 2 and the capital A is 1. So it becomes 1 over small letter a is 2 plus j omega. Same goes to the other component. Okay, so next, solve the complete operation in which you have multiplication in the amplitude by 3 and both signal being added up. So your f omega equal to 3. This is the one on the left and one on the right. So being added up, so then simplify this equation. So if you refer to the second step, so from the table, basically you can have the same shape of equation. So in this case, this is equal to AE minus A modulus T. So in this case, you know that your small letter a equal to 2 and your capital A equal to 3. So in Fourier transform, this equation will produce this. So straight away, you can replace all a's into the equation. Okay, so in this case, this equation will produce 12 over 4 plus omega squared. So if you compare both steps, produce the same answer. Okay, let's look at the second example on superposition or linearity. So find the Fourier transform of GT. So in this case, this is your signal GT. So if you look at the shape, it's basically a combination of rectangular function. So you can choose how many components you want to have in your equation. For example, in this case, I'll divide this signal into two. So the first one is this one. And the second one is the bottom one. Okay, so GT is basically G1T plus G2T. If you total them up, you'll get GT. Okay, so how to use Fourier transform in order to get this solve? So you need to refer to the table. So basically, you need to refer to rectangular function. if you remember basic equation of rectangular function, it is a rectangular t over tau. A is the amplitude of the rectangular and tau is the width of the rectangular. So in this case, on the first one, G1t, so the equation will be A rectangular t over tau, the width. So the width here is 6. So for the second signal, so A is 1 rectangular t over tau, the width is 2. Okay, once you have the equation in time domain, so you can convert the equation into frequency domain. So obviously the rectangular function in time domain will produce sinc function in frequency domain. So to avoid confusion, so just refer to the Fourier transform table. So the rectangular function will produce a sinc function, a tau sinc function omega tau over 2. So now you need to work on both signal G1 and G2. So after you get the equation in time domain, so you need to convert those equations into frequency domain. So if you compare the first signal G1t, so it will produce G1 omega, in which it is equal to a tau sinc function omega tau over 2. So in this case, your A is 0.5, tau is 6, multiplied with 6, sinc function, omega tau, tau again is 6 divided by 2, so we get 3 omega. Same goes to the G2. Okay, so GT equal to G omega is a summation of G1 and G2 in frequency domain. So this is as discussed just now. So you have the A multiplied with tau sinc function omega tau, the first tau over 2, and the second signal. So the A is 1, A tau for the second signal. So the tau is 2, A tau sinc function omega tau over 2. So simplify the equation. So the first transform of GT equal to G omega given by this equation. Let's look at another example on linearity and superposition. So given V1t, V2t, the A and B. Okay, so if you have A V1t, will produce A V1 omega in frequency domain. So same goes to when you have BVT, V2t, so it will produce BV2 omega. And if you have a new signal RT, is the combination or the superposition between the first signal and the second signal. So R omega will also having the same summation of two signals in frequency domain. So in this case, given V1t equal to UT, so AV1t equal to 8 UT. So A in this case given by this value. So 8 V1 is given by U. So in this case, A V1t equal to 8 UT. So find the A V1 omega. So refer to the table. So when you have signal with unit step function, so it will produce this in frequency domain. So in this case, your equation equal to 8 UT, in which this is equal to A V1t. Okay, so in this case, your A equal to 8 and then UT. So here your A equal to 8. Okay, so the signal, the first signal, AV1 omega. So this is your AV1 omega equal to this equation. Okay, next you need to work on the BV2. So BV2, so BV2t. So your B is 20. So V2 is given by this exponential j 2000 t. So again, refer to the table. So you need to find what is bv2 omega. So we need to find what is bv2 omega. So in this case, when you have exponential function, so you have in frequency domain, the signal will be frequency shift. In this case, your ej omega naught t equal to ej 2000 t. So you know that your omega naught equal to 2000. Okay, so your bv2 omega, so this is your bv2 omega equal to 2 pi omega minus omega naught. So omega naught is equal to 2000 in this case. So now work on r omega. So r omega equal to the combination of both signal AV1 omega and BV2 omega. So just add them up. Okay, so R omega equal to, so this is your AV1 omega plus BV2 omega. Okay, let's look at the next properties, time shift. So if you recall back, when there's operation inside the bracket in time domain, so it is time-based operation. So if you have time shifting in time domain, so you'll be having exponential, the signal being multiplied with exponential function in frequency domain. Okay, so time delay is time shift in time domain causes linear phase shift in frequency domain. Okay, however, the amplitude remain the same. Okay, if you have the amplitude 1, so the amplitude here also 1. And let's look at an example in time shift operation using Fourier transform. So if you have a Vt is given by Ut and you need to Rt, a new signal is given by Vt minus 7. So you'll notice that the original signal now being shifted by 7. Okay, so to determine R omega, so here you need to find R omega. Okay, the first step, refer to the table and compare to the equation you have. So the first one, you have Vt equal to Ut. So Vt equal to this equation. So Vt equal to Ut. So you need to find what is V omega. So V omega equal to A equal to this equation. So what is your A? So in this case, your A is AUT. So your A is 1. So it's 1 and the one in the bracket pi delta omega plus 1 over j omega. So this is your V omega, the first equation. Now find the R omega. So R omega having the original signal being shifted by T naught. So in this case, compared to the given equation, Vt minus 7. So you know your T naught in this case equal to positive 7. So you have your equation V omega E minus J omega. Your T naught is 7. And then what is V omega? So V omega is from the first equation. So you need to replace equation 1 into the second equation. Okay, so now the V omega equal to this from the first equation. So R omega equal to V omega multiply with exponential of E minus J 7 omega. Okay, another example in time shifting. So you'll notice you have time shifting here, T minus T naught. So your T naught in this case equal to 0.5. Okay, so compare with the table. The first step, always refer to table. So in this case, you have this equation, AE with modulus T. So it will produce this equation. So compare this into this one. So AE minus AT. So you know that the capital A equal to 3 and the small letter a equal to 2 and your T naught equal to 0.5. Okay, so now you have your basic equation. So Ft equal to 3e minus 2t. So it produces F omega equal to 2 capital A equal to 3, small letter a equal to 2 divided by a squared, 2 squared plus omega squared. So this is your F omega. So now you have a new signal being shifted. The new signal dependent on the original signal, Ft signal, but the signal being shifted by T naught. Okay, so now if you have the signal being shifted by T naught, so the Fourier transform equation equal to F omega E minus J omega T naught. So you know that this T naught equal to 0.5. So this T naught equal to 0.5. So what is F omega? So F omega is from the original equation. Okay, so your F omega here equal to, so Ft minus 0.5 equal to F omega E minus J omega 0.5. So what is your F omega? So F omega equal to 2 times 3, 6, 12. So 12 over 4 plus omega squared multiply with E minus J omega over 2 or 0.5. Okay, so this is your new signal. So we can call this one as F new, for example. Right? With that, thank you.